This is day 1 of factoring. We're going to take a look at factoring using the GCF and also when a is equal to 1. There are 4 parts in today's notes. Starting with the first part, I want to go over some vocabulary. If we take a look at numbers 12 and 30, we're going to list out its factors. Now, factors are numbers that you multiply together to get another number. So for example, 2 times 3 would give me 6, so 2 and 3 are factors of 6, but also 1 times 6 would give me 6. So 1 and 6 are also factors of 6. Starting with number 12, I know that I can multiply 1 and 12, 2 and 6, 3 and 4 to get 12. For the number 30, I can do 1 times 30, 2 times 15, 3 times 10, and also 5 times 6. Now that we have all of the factors listed out, I want to identify what the common factors are between these two numbers. Now, common factors are factors that 2 or more numbers share. So if I look at the numbers, they both have 1. So 1 is a common factor. They also have 2, 3, and 6. What we're interested in is finding the greatest common factor, or the GCF, you'll hear me call it. And the greatest common factor is the largest number that is in the numbers that they share. So it's the largest or the greatest common factor. Well, out of these 4 numbers, the greatest factor would be 6. So 6 is the GCF. Part 2, we're going to practice finding the GCF. Starting with number 1, you want to look at not only the numbers, but the variables as well. The factors of 6 are 1 and 6, 2 and 3, and then we have an x squared. So if you ask yourself what numbers or variables do you multiply together to get x squared, well, that would be x times x. 5, the only factors of 5 are 1 and 5. It has an x squared, so that also would have 2 x's. Again, x times x is x squared. Now, if I want the greatest common factor, I want the largest number that they share. Well, the largest number that they share is 1. In fact, that's the only number that they share. So the GCF here is going to have a number 1, but also we can pull out variables. So I think of this as making pairs. How many pairs can I make? 1 pair, 2 pairs. So I can pull out 2 pairs of x's, and that would be x squared. Number 2, factors of 15 are 1 and 15, 3 and 5. We have 3 y's because it's y cubed. For negative 20, even though it's negative, still treated the same way. The factors are 1 and 20, 2 and 10, and then 4 and 5. There's only 1 y in this case because it's y to the first power. If I want the GCF, then I'm going to have to look at the greatest common factor, so the numbers first. They both have a 1, but they also both have a 5. So 5 is a larger number. And then how many pairs can I make? 1 pair. You can't make a pair within a term itself. It has to be 1 y from one term, 1 y from another. Next, factors of 4 are 1 and 4, 2 and 2. There's 2 x's. Factors of 5 are 1 and 5 and 3 y's. The GCF here, if I'm looking at the numbers, it would just be 1. In fact, that's the only common factor they have. Now, if I'm going to make pairs of the variables, I actually can't make any pairs because these are x's and these are y's. So they're not the same variable. meaning that the GCF is only 1. Number 4, the factors of 8 are 1 and 8, 2 and 4. There's 2 A's as well. And for 28, we have 1 and 28, 2 and 14, 4 and 7. The GCF here, common factors are 1, 2, and 4. The greatest common factor would be 4. Okay. Part 3. So now what we're going to do is we're going to factor by pulling out the GCF. All we've done so far is practicing finding the GCF. So I'm going to start off with this example here and display the 2 steps that we're going to do. So the first step is to find the GCF. Again, this is what we've already been doing. Looking at these numbers, I have 15, so that's 1 and 15, and then that gives me 3 and 5, x, x, x. And then here I have 1 and 6, 2 and 3, x, x. Here I have 1 and 21, 3 and 7, and x. So in this case, there are 3 terms, not just 2. So we have to look at what do all of them have in common. Well, they all have a 1. They also all have a 3. So if I'm thinking at the numbers, 3 would be the greatest common factor. So I'll put GCF. There's a 3. And then how many pairs of x's can I make? Well, all 3 of them have to come into play. So there's 1x here, meaning I can pull out 1x's there. But that's the only set that I can pull out. All right, step 2, we need to divide each term by the GCF. So the way we're going to write our answer, the GCF is going to be on the outside, and then in parentheses, we're going to have whatever remains. So my answer is going to be 3x times something. Well, 15x cubed, so 15x cubed divided by the GCF, 3x. 15 divided by 3 is 5. X cubed over x, you just subtract the powers, so 3 minus 1 is 2, so x squared. Minus, I'm keeping the sign, 6x squared divided by 3x, 6 divided by 3 is 2. X squared divided by x, 2 minus 1 is 1, so x to the first power. Plus, keeping the sign, 21x divided by 3x. 21 divided by 3 is 7, and the x's cancel out, or 1 minus 1 is 0, so there are 0 x's. This is my final answer. Now, you don't have to write all of the factors every time. You can just ask yourself, what is the largest number they're divisible by? And I'm going to do that here. Okay, number 5. If I'm looking here, my GCF, starting with the 4 and the 6, those are both divisible by 1 and 2. 2 obviously would be the GCF there. And then when I'm looking at the x's, essentially what we're doing is we can pull out the smallest power if each term has that variable. So x squared and x to the first power, the smallest power would be x to the first power. The GCF is 2x, and then in parentheses I need to put what remains. So 2x squared divided, or 4x squared divided by 2x, 4 divided by 2 is 2, x squared divided by x is x, plus 6x divided by 2x, 6 divided by 2 is 3, x over x, the x's cancel, so I'm just left with 3. Let's try this again. Number 6, the GCF. Both terms are divisible by 3. And only one term has the x, this one doesn't, so I can't pull out a variable at all. 3, my GCF goes on the outside, and in parentheses, I'm going to write what remains. So divide both terms by 3. 3 divided by 3, that's 1, or they essentially cancel, leaving me with just x. minus 6 divided by 3, which is 2. Number 7. 10 and 5 are both divisible by 5, okay? But the 2 isn't, so I can't pull out a 5. I have an n cubed here and an n here, but I don't have an n here. So I can't really pull out an n either, because all 3 terms should have that variable. Really, I can't do anything. The only greatest common factor that they would have is 1, because everything's divisible by 1. So when I'm rewriting my final answer, it's essentially the same. The GCF was 1, so I can't really factor it by using a GCF. Number 8. Looking at all 3 terms, I always like starting off with looking at the numbers. So 9, 18, and 6. Okay, well, they're all divisible by 1. Okay, they're all divisible by 3. Are they all divisible by 6? No, because I got that 9, but this one was. So it looks like my GCF would have a number of 3. And now I need to see if I can pull out any variables. So I have 8 h's here, 3 h's here, but only 2 h's here. So I can make 2 pairs or 2 sets. So I'm going to put h squared. Or remember, it's essentially the lowest power if each term has the variable. If I pull out a 3h squared, in parentheses, I need to write what remains. So all 3 terms are being divided by 3h squared. 9 divided by 3 is 3. H to the 8th power divided by h squared. Well, 8 minus 2 is 6, so h to the 6th power. Plus 18 divided by 3, that would be 6. H cubed over h squared just gives me h to the 1st power. Minus, because I'm keeping that sign, 6 divided by 3 is 2. H squared over h squared, that becomes 1, so essentially they're gone, leaving me with just 2.